Good morning, students. So we have started discussion on the MSP430 architecture. Okay. So today let us study the pinout diagram of one of the MSP430 series microcontroller, that is MSP430 F2013. Okay. So as you can see here, this F2013 is a 14-pin IC. Okay. It has 14 pins. Okay. So let us go through these pins one by one. Okay, so this pin number 1 and this pin number 14, they are used to give the supply to this MSP IC. Okay, so this is the positive supply pin and this is the negative supply pin. Okay, so that is VCC and VSS. Okay, so the pin number 1 and 14 are used for giving power supply to this IC. Okay, next, as you can see here, almost all the pins of this F2030 microcontroller, they are multiplexed. That means these particular pins, for example here this pin number 2, so it can function as either the one of the port pins P1.0, or it can function as the second function, that is TACLK, or it can be used for this third function, that is ACLK, or it can be used for this fourth function A0+. So as you can see here in this pin diagram, most of the pins of this F2013 microcontroller are multiplexed. That means they are capable of performing more than one function. Okay, so let us go through these pins in detail. So this, if you use this pin number 2 for this first function, okay, P1.0, then this pin will act as the bit 0 of port 1. Okay, so similarly there is one more bit, that is P1.1, P1.2, P1.3, P1.4, P1.5, P1.6 and P1.7. So as you can see, there are 8 pins available in port P1. Okay, so in this F2030 microcontroller IC, okay, so there are 8 pins, 8 bits in the port P1, P1.0 to P1.7. And as you can see here, there are only 2 bits available in port P2, that is P2.6 and P2.7. Okay, so in port P1 we have 8 bits available for the user, and in port P2 we have only 2 bits available for the user, that is P2.6 and P2.7. Okay, then as we know, in this MSP430 series microcontroller, internally it uses different types of clocks. Okay, so if you select this pin number 2 for this function, so that is ACLK, okay, then what it indicates, so internally there are clocks such as ACLK and MCLK, SMCLK produced by the microcontroller. So if you choose this pin number 2 for this third function ACLK, then that internally generated ACLK clock is made available on this pin. So the clock pulses that is generated, the clock pulse ACLK clock that is generated internally by the clock generator, it is made available on this pin number 2 for this function. Okay, similarly you can see here, so for pin number 6, if you choose this second function, then the SMCLK submaster clock that is generated internally by the microcontroller is made available on this pin number 6. Okay, then next, as you can see here, we have pins such as A0 plus, A0 minus. Okay, so these two are used for giving input to the analog input to the ADC, that is A to D converter, that is one of the peripheral that is available inside this MSP430 F2013 microcontroller. So inside this IC microcontroller there is an analog to digital converter. Okay, so for that we need to give the different analog inputs. So here for giving one analog input, the 2 pins have been made available, that is A0 plus and A0 minus. Okay, so this is called as differential input. Okay, so for giving each analog input to this A to D converter in this F2013, we have to give 2 inputs, that is called as differential analog input. So this is A0 plus and this A0 minus, these together constitute one analog input channel. Okay, similarly we have A1 plus and we have A1 minus, this is the second analog input for the ADC, either we can give the second analog input here. Then we have A2 plus and we have A2 minus, the third channel where we can give the A to D analog to digital converter input, analog input we can give here A2 plus and A2 minus, or we can give one more input here, that is A3 plus and A3 minus. Okay, so we can give the first input. Okay, here we can give one input between these two pins, analog input. We can give second input here, we can give third input here, we can give fourth input here. Okay, and there is one more channel, that is A4 plus and A4 minus. Okay, we can give one more input here between these pins. So these are the different analog input channels. We can use it for giving the analog input to the built-in A to D converter inside this microcontroller. Okay, then as you can see here, there is one more function that is called as TACLK. So if we choose this pin number 2 for this function, then this pin number 2 can be used to give the clock input to the timer. So remember, in this MSP430 IC microcontroller, there is a timer inside, built-in timer, that is called as timer A. So we can give the clock, external clock input to that timer by using this pin, that is TACLK. Okay, so that is the function of this TACLK. If we choose this pin number 2 for the second function, we can give the clock to the timer A inside this MSP430 IC. Okay, and we have next this one, TA0, okay, and TA1. Okay, so if you remember, in the RF controller we have studied what? The timer. So as you know, the timer can perform two operations. One is it can perform the capture function or it can perform the compare function. Okay, so this TA0 and TA1, if you select these pins, pin number 3 and 4 for TA0, TA1, okay, they can be used either for giving the capture inputs so that the timer can capture, you can perform the capture function, or you can use these two pins TA0, TA1 for compare output. Okay, so in the timer there are two functions available, one is capture function and the compare function. So these two pins can be used for either giving the capture input or for giving the compare output. Okay, these two are the pins TA0, TA1. Okay, as you can see here, this TA0 is available on this pin also. Okay, and this TA1 is available on this pin also. So this TA0 is available here also, and TA1 is available in this pin also, in this pin also. What is the difference for, what is the importance of giving it here also and here also? That same functionality is given twice here. So here this TA0, it can be either used as the input or the output. Input means capture input, output means compare output is available on this pin. If you select this TA second function on this pin number 3, now if you select this TA0 function for this pin number 7, if this pin number 7 is selected for this 7 function, then only the compare output is available on this pin. We cannot use it for capture input. Okay, so this pin number 7, when it is selected for this TA0, it can only function as an output pin. Output means the compare output is available on this pin. Whereas if you select this pin number 3 for TA0, this function here, then you can use this pin as either the input pin or the output pin. That means we can give the capture input on this pin or the compare output is made available on this pin. Okay, so these two pins TA0, TA1 on this pin number 3 and 2, they can act as either input pins or the output pins, whereas the TA0 and the TA1, which are available on pin number 7 and 8, they can only act as the output pins. Okay, so just remember that. Next, this V reference. Okay, so this is used to give the reference voltage to the built-in A to D converter. Okay, so as just now we discussed, this F2013 has a built-in analog to digital converter. So these are the A00, A0 minus, these are the differential inputs for the built-in A to D converter. That A to D converter, to function, it needs a reference voltage which can be given on this pin, that is pin number 5. Okay, then coming to these pins here, we have TCK, okay, and this TMS. Okay, so these two are used for the JTAG testing purpose. JTAG testing means whenever I have written a program in my PC and I want to put my program in this IC, so I can do it by using the JTAG interface which is available in this IC. So for that function we can use these two pins. Okay, this TCK stands for test clock, okay, and this TMS stands for test mode select. Okay, so these two are related to JTAG functionality for programming the device, for programming this F2013 and for testing purpose. Okay, so just remember that. Then we have the one more pin here functionality, that is called as SCLK, serial clock. Okay, so this can be used as the serial clock in case of serial communication. Either it may be SPI or I2C. This pin will be used for serial clock function. Okay, then coming to the remaining pins here. Okay, so here we have SDI, okay, and we have SDO. These two functionalities are related to the SPI function. That is, SPI stands for serial peripheral interface. Okay, so in that case, if you want to use the SPI for serial communication, then the serial data input is available on this function and serial data output is available on this function. So these two, SDI and SDO, serial data input and serial data output, these two are related to the SPI functionality of this IC. Okay, for serial peripheral interface, that is for serial communication. Then we have SDA, serial data, okay, here, and we have SCL, serial clock. So if you remember, in this MSP430, okay, internally it has got the I2C capability, that is it can get connected to an I2C bus. Okay, so I2C, as we know, it has two lines for communication. One is serial clock and the other one is serial data. So these two lines are the means of communication for getting this IC connected to the I2C bus, that is serial clock and serial data. Okay, then we have TDO, okay, test data output and test data input. So this TDI is available here also. So this TDI, test data output and test data input, and this test clock. So these are related to the JTAG functionality. So JTAG interface is used for placing the program or programming this device. So suppose I have written the program in my PC and I want to put that program in this IC. So I can place my program that is written in the PC into this IC by using JTAG interface. Okay, so for that purpose we are going to use this TDO and TDI and TCLK, test clock. Okay, then there is one more pin, that is pin number 10. As you can see here, it can be used for active low reset input. Okay, so you can use this pin. If you use this pin number 10 for this function, we can reset this microcontroller. Okay, so this is RST bar. That means if you give low value on this pin, then the processor can be reset, provided you select this pin number 10 for this reset function. Or if you don't want to use this pin number 10 for the reset function, you can use this pin number 10 for the next function, alternate function, that is NMI. NMI stands for non-maskable interrupt. Okay, so if there is any interrupt coming from the external world, that can be given to this pin, that is non-maskable interrupt. Okay, so this pin number 10 also has got the third function, that is called as SDUSDATDOTDI. Okay, so this SDUSDATDOTDI and this function, that is SDUSDWTCK, this SPW stands for SPI by wire. Okay, so as you know, for programming the device and for testing purpose, we are using the JTAG interface on this IC. Okay, so the same programming and testing can be done by using only two wires, that is these two pins. Okay, that is SPI by wire. Okay, so this SPWTDIO stands for SPI by wire, test data input and output. SPI by wire, okay, SPI by wire, test data input and output. Okay, so the data can be input and output on this pin, and this is the clock for that SPI by wire interface. Okay, so the programming and the testing of this MSP430 F2013 can be accomplished in two ways. One by using the JTAG interface, or either we can go for using the SPI by wire interface. Okay, and this test pin number 11, this functionality, it is used to select the JTAG modes which are available on this pin number 1 port pins. Okay, so many of the pins on this port P1 they are used for the JTAG purpose. So for selecting in which mode those pins are going to operate, we can use this pin, that is the test pin. Okay, then we have X in and X out. Okay, we have X in and X out. So these two pins are used for connecting external crystal between these two pins so that the internal oscillator can run. Okay, so this is X in is the input pin and this is the input pin and this is the output pin. Okay, we can connect a crystal between these two pins so that this IC can comfortably generate the internal oscillator. That is, internal clock can be generated with the help of this external crystal. Okay, so this TA1 is again, it is related to what? The capture and compare output. Okay, so that is available on this pin TA1. Okay, so this is all about the pinout of this MSP430 F2013 microcontroller. Thank you.